Kubernetes services enable communications with various components within and outside of the applications. It helps us connect applications together with other applications or users. It provides loose coupling between microservices in our applications. So the loose coupling are tightly coupled. What is this loose coupling? So when we talk about the microservices, so in monolithic applications, what happens? All these things are tightly coupled. If anything is breaks, all your applications down. But this loose coupling means one thing is break, other things will manage, right? Your microservices, your entire applications will not impact. Now, what happens here? We have different types of services. We have NodePort, ClusterIP, and load balancer. Okay, we have NodePort, ClusterIP, and load balancer. These are three types of services. These are the three types of services. Let's understand in details and more what is a NodePort. Okay, when should I go for a NodePort? When should I go for load balancer? Okay, so the first let's go with the ClusterIP. So a ClusterIP service is the default Kubernetes services, right? So if I just go to this here, to the cluster, if I just use kubectl, okay, kubectl, just type services, right? Kubectl services. Sorry, what is the command, guys?
kubectl get SVC.
Exactly, get services or SVC. That is a short form. See, the default is the ClusterIP services. So if the services is actually, if you are feeling that's long, so you can use a short form SVC. As I was telling in our last class, there are a few short forms you can use it. Now, if I just go here and check, let's see more details. What is this ClusterIP? ClusterIP service is the default Kubernetes service. By default, once Kubernetes you install, it will create the ClusterIP. It gives you a service inside your cluster that other apps inside your cluster can access. There is no external access. So it is between the applications inside the clusters, the pods, whatever the pods is having, the communications between those, it will need the ClusterIP. You don't have to set up it, right? If you want to create a ClusterIP separately, you can just go ahead and this is the manifesto file, or this is the configuration, the definitions file you have to write, API version v1, kind service, metadata is name sections, and the type we have to just select as ClusterIP, what type of things you want. So that's how you have to create it. So we can access the ClusterIP service from the internet by using the Kubernetes proxy. So mostly we don't use this ClusterIP service. So if you want to use from the internet, as it is internal, this cannot be accessed through the externally from the outside. But still, if you want to access, you can use the proxy to access this one. If you see this diagram here, right, we have this Kubernetes cluster services, and these are the pods. And this service is nothing but your ClusterIP. Through proxy, you can connect it. Okay. So what is the NodePort? So more details we have how we can do when we use this ClusterIP. There are a few scenarios like debugging your services or connecting to them directly from your laptop from some reason. If you're debugging something, if you're troubleshooting something, you need to directly connect to those applications. So you can go ahead with the ClusterIP and just connect. So allowing internal traffic, displaying internal dashboards, etc. Why you need this? Because this method requires you to run kubectl as an authenticated user. You should not use this to expose your service to the internet. Normally, we never expose the internal things to the internet, right? So that's the cluster IP. Rarely use for troubleshooting part, but mostly no. The other one is the node port, right? What is this NodePort service? A NodePort service is the most primitive way to go get external traffic. Most primitive way to get external traffic directly to your service. And NodePort, as the name implies, it opens a specific port on all nodes or the virtual machines or whatever, and any traffic that is sent to this port is forwarded to the service. If you see here, the manifesto file or the definition file, I'll just tell you later. But just now, when we do the demo, right, we have to create the services. I'll explain that time more. But just have a note. Kind is service, type is node port. That time, the cluster IP, the type was cluster IP. And here the type was node port. Okay. Now, the diagram, if you see here, we have the Kubernetes cluster, right? We have this Kubernetes cluster. Now, we need to access this service, access these pods. We have to access these pods from these VMs. How will do that? We have to expose the internal or cluster pod, Kubernetes, the pod, to the external traffic. To the external traffic, we have to just expose those things. To expose that, so this type in NodePort. Okay, so you have to, what you have to do, a target port, target port, and node port is 30036. Node port is 30036. So why we have to give 30036? So there is a range of the port you have to select. I'll tell you that range up to from, I think from 30 to 32. Okay, I'll just explain you. So what happens here? You have to give a port. Through this port, we can access the pod from externally in the internet. Okay, from the internet, you can access externally all the pods. Now, when we should use this? So when you can only have one service per port, because for each service you create, you will have multiple pods, right? You have to create multiple ports. That is actually downsides. Means it says there are many downsides to this pod method. If you're going for development, or you're doing demo, you're demonstration something, you're doing R&D, or you need to do the setup, so you can go with NodePort. You have to create few ports and select it and do the testings and do the development and all this. But when you go to the productions, NodePort is not the ideal choice. NodePort is not the ideal choice, right? So you can only have one service per port, and you can only use ports between the range 30,000 to 32,767. The port range should be in between. So you can create 2,767 ports only. If you have beyond this, you cannot create the services. If your node or VM IP address change, you need to deal with that. Obviously, if the IP address changes, you have to fix it. We have to change the services, ports, and everything. Then you have process. So what it says, it is not recommended to use this method in production, whatever I just told you, right? So it is not an ideal solutions or ideal service to use in the production. If you are running a service that does not have to be always available, if you are running a service that does not have to be always available, or you are very cost sensitive, this method will work for you, right? That's why, see, load balancer, ingress, and those are actually costly. You have to pay something. That's why in development, R&D, and all this kind of testing and all, we normally use NodePort, right? So, as I said, for demo applications or something temporarily or something you're doing development, you can go with this NodePort. The other one is the load balancer. Other one is the load balancer. So why we need this load balancer? A load balancer service is the standard way to expose a service to the internet. It is a standard way to expose the service to the internet. So what happens here? On GKE means Google Kubernetes Engine. As this Kubernetes is developed and designed by Google, right? Designed by Google. So it uses JKE, Google Kubernetes Engine. This will spin up a network load balancer that will give you a single IP address and that will forward all traffic to you. So if you are using GKE, Google Kubernetes Engine, or Google products, right, our cloud, right, that times you have to, whatever network load balancer will get created. If you are using GCP, right, Google Cloud Provider, you have to use GKE Kubernetes Services. As see, Kubernetes, you are learning Kubernetes, the raw things, right? There are in the market, there are many service providers, even cloud service providers. They provide managed service applications. Those applications which already being defined, redefined, all these Kubernetes things are there. So you have to use few commands and everything will be done. Like AWS is EKS, right? Elastic Kubernetes Service. And here Google Kubernetes. And Azure also we have AKS, AKE or AKS. Like that, many cloud service providers, many companies, they provide. So load balancer, when should you use it? If you want to directly expose a service, this is the default method in production. All traffic on your port you specify will be forwarded to the service. There is no filtering, no routing, nothing. So you have to use the traffic using the HTTP, TCP, whatever it is. It has also a big downside of a load balancer. What is that? Each service you expose with load balancer will get its own IP address. Its own IP address, which is costly. And you have to pay for a load balancer for exposed service, which can get expensive. In Kubernetes, to overcome this problem, we have ingress. We have ingress. So what is this ingress? Actually, companies were implementing Kubernetes in their process and their organizations. They use definitely ingress. So you get definitely questions. So what you're using? Suppose if you're using for a multi-tier company, so you can tell easily ingress. But if you're working for a small scale company or some companies who cannot afford lots of things, you can go with you can say we have a few pods are running, or you can go with NodePort. You can say even NodePort we are using, but our company will not afford that much, right? Load balancer, as it is expensive. Your company, if you're not earning that much, how they'll afford this load balancer, right? So load balancer, most of the company they use it as it is expensive. They go with this ingress. Ingress also uses the load balancer, but as we said, load balancer for each services it will create the new IP addresses if you're going with only load balancer. But using ingress, load balancer will control that. Sorry, Ingress will control the IP creations and everything will be managed in Ingress. So it will minimize your cost. So what is that? Ingress is actually not a type of service. Remember, that's why initially I showed you only three type of services: NodePort, ClusterIP, and load balancer. Ingress is not a service. Remember, guys, it is actually not a type of service. Instead, it sits in front of multiple services and act as a traffic police. Okay, act as a traffic controller or smart router. You can say the router just routes the traffic, right? The router routes the signal to different paths. As the traffic police, what it does, same thing, it will be sitting ideally and transfer the traffic to the different path. So what it says, you can do a lot of different things with an ingress, and there are many types of ingress controllers that have different capabilities. The default JK ingress controller will spin up HTTPS load balancer for you. This will let you do both path-based and subdomain-based routing to backend service. Here is the point. Now, when we go with load balancer alone, what happens? For each service it exposes, it creates the IP addresses, which is expensive. But if you keep ingress in front of that, is sitting one router there, what it does, it is not, you don't have to unnecessarily create the IP address. What it does, it can redirect the traffic using the path based and subdomain based. If you're purchasing a domain, you have to pay for that, right? Subdomain, no, you can create based on the subdomains, maybe multiple or n number of subdomains based on the service provider you're choosing. So path based, for example, you can send everything. See, I have suppose a subdomain called book.ranjitswain. I have suppose ranjitswain.com is my domain, where I have created a subdomain for book.ranjitswain.com for suppose only I'm a retailer, e-commerce retailer. I'm suppose selling only books. I can create a book.ranjitswain, or I'm selling clothes, or I'm selling whatever goods, right? Provide that name with a subdomain and use that one. So what happened of this service, and everything under this particular path will be redirected to this one. Let's see this in example in the diagram. If you see here, this particular diagram, right? If you see this particular diagram, what happened here? We have different things, services are there. We have suppose one domain here, another domain, okay? And all the services, I have suppose cloth business here, book business or food business, whatever it is. I can just, all this service I just exposed, add those particular domains. Using this traffic ingress controller, it will automatically, whatever applications you choose, it will just redirect those traffics. Redirect those traffic. So here you can see the extensions, how to use. So if you see here, we have this API version, extensions, v1, beta 1, kind, ingress, right? And here, the services host you have to provide, and the path, which path you have to provide to go. We'll see in details, but ingress, it will be, as I said, load balancer ingress, we cannot do the demo. It will charge you more, okay, if you create it. So just go ahead and just do whatever the ingress things we have learned so far. Just do practice, not practice, just go through and make all these things. If you can do practice, you can do that. Just go with more in details in advanced, okay? You can find all the details there. Okay, guys, that's all for today's class. I think we have completed most of the advanced things, and maybe tomorrow, next class, we'll go with further advanced sections of storage, how we do the volumes, persistent volume and all. That's most important. With all this, once we complete this persistent volume, we'll have them make one project, end-to-end project that we'll do in details. Okay, so tomorrow class, we'll do one small demo with having NodePort. to see how we can access those things, and then we can go. Okay, guys, that's all. If you have any doubt, we can discuss, or else we can wind up this call and connect tomorrow.